In this lesson, we'll talk about linear equations. We're going to first define what a linear equation is, talk about some terms that relate to linear equations, and then we'll do some solving of linear equations. So first, let's get to the definition. And so you can see here that it's an equation of the form ax plus b equals 0. A and b have to be real numbers, and a can't be 0 because then you lose the x term, and you just have a constant sort of function there. So we're going to look at 4 examples and decide which of these are linear equations and which of these fit the definition. So if we look at the first one, because of this x squared term here, we know that this is not a linear equation. This next one has x squared as well, but if you look more closely, if we move everything over to the left, we end up with x plus 2 equals 0, and that is linear. And then this one, you might be tempted to factor and then cancel, leaving you with x plus 2 equals 0. But this is actually not linear because linear functions are continuous. And this one, if you notice, the domain is x cannot equal 2. So therefore, it cannot be linear. And then lastly, the root in the final example here is the reason that this is not linear. So there you have it, 4 examples, only one of which is actually linear. So some terminology that we're going to talk about. So the first thing is solution. And solution is just the value for the variable that satisfies the equation. And by satisfies the equation, we just mean makes the equation true. Okay, root, and more specifically root of an equation, not to be confused with square root or cube root or any of the roots involving radicals. This is of the equation. And when we say the root of an equation, it's the same as a solution. So a number that makes the equation true is called a root. A solution set is a collection of solutions. We know that some equations are going to have more than one solution to them. So we call the solution set basically that whole collection. So it's a collection of solutions. And sometimes when there's no solution, we say it's an empty set because the solution set is empty. There's nothing in it because there are no values that will make the equation true. So it's a collection of solutions. And so a lot of times you might see it like that, which is the same as empty set or null set. If we've got multiple solutions, right, sometimes you'll see that as, 2 is a solution, -3 is a solution, 5 is a solution. We sometimes have infinitely many solutions where we might say that we have ordered pair xy such that 3x plus 4y equals 9. You may also see x such that x equals 5 and -2, right? So there's different ways to write a solution set. And you'll familiarize yourself with all of these as we move forward. An identity is basically an equation that's always true. So an example would be 3 times 2x plus 4 equals 6x plus 8. 12. No matter what you plug in to that equation, it will be true. And then by first degree equation, we just mean a linear equation. Because notice that the exponent on the x, or on the variable in a linear equation, is 1. So we call it a first degree equation. So there's some terminology that you need in dealing with linear equations. And now we have a few examples that we're just going to solve and talk about some techniques. So we want to solve each one, but before we do, we want to make sure that we list any restrictions on the domain. So in this particular one, the domain is all real numbers. There are no restrictions. And since we're dealing with fractions, we're going to multiply through by an LCD and get rid of all the fractions. So the LCD is 12. So I'm going to take the whole equation, multiply by 12. And so that gives me 8y minus 6 times y minus 3 equals 3 times y plus 1. And now we're just going to simplify each side. So 8y minus 6y, that's 2y, and I'm going to bring that over to this side to just give us y, and then bring the 3 to the left. So y is equal to 15. And so that is the solution, or the root of this equation. In this example, again, we're dealing with fractions, so we're going to multiply through by the LCD. But notice first and foremost that our domain is x cannot equal plus or minus 2. And we should probably factor this. And so we can see that our LCD is x plus 2x minus 2. And I'm going to multiply the entire equation by x plus 2x minus 2. So I end up with x plus 5 times x plus 2 minus 5 times x minus 2 equals 28. So x squared plus 7x plus 10 minus 5x plus 10 equals 28. X squared plus 2x, and then that's going to be a plus 20, and we're going to bring that over, so that's minus 8 equals 0. We can factor. So x plus 4, x minus 2, and so x equals negative 4, comma 2. But remember that 2 is not in the domain, so x equals negative 4 is the solution. And notice there that that's actually not a linear equation, but we still have the skills to solve it. Okay, this one here, a fraction equal to another fraction, we're just going to cross multiply. And remember, we are solving for x. So a, b, and c are actually considered constants here. X is the only variable. X minus a equals b minus c times x plus a. And so let's FOIL these out. So I get a bx minus an ab plus a cx minus an ac equals a bx plus an ab minus cx minus ac. So the bx's cancel, the negative ac's cancel, and so I get 2cx equals 2ab. The 2's cancel, and divide everything by 2c, and end up with x equals ab over c. And what we want to be careful, remember, domain is x cannot equal plus or minus a. So our answer checks out. We're good to go. And then lastly here, the domain is x cannot be 0, and our LCD is ABCX. So I'm going to end up with BCX minus ACX equals ABX plus ABC. Since I'm solving for x, anything with an x needs to get on one side of the equation. So let's bring the ABX over. So BCX minus ACX minus ABX equals ABC. Factor out the x. and then divide. And there we have it. So those are 4 examples. Remember that the second one is technically not a linear equation, but something that we were able to solve anyway. And thanks for watching.